So again, what rules do we put in? I put the tuna up there, but I could have put an Alaskan pollock up there, just easier to keep using the same picture. We saved the Alaskan pollock. They were going to go away. They were going to go extinct. Okay, so the Alaskan pollock almost went away. And because we instituted rules and regulations and changed things, we pull a couple of billion tons of Alaskan pollock out of the Alaskan waters every year, and it's not nearly in danger of going away. In fact, those populations are growing. When we made those rules, it hurt Russian and Japanese fishermen who'd been coming over and fishing those fish. They're not allowed to do that anymore. But over time, it made American fishermen way better off because now there's this huge Alaskan pollock, but it's about people working together. We have rules about coal, and again, if coal is creating mercury poisoning, which is hurting the tuna industry and hurting us, then rules, trade-offs, what's the answer? And of course, burning coal also creates carbon dioxide, carbon monoxide, acid rain, other things in the atmosphere that have negative impacts on other things. This coal creates externalities. What's the way to deal with the externality? And what's the value of the coal miners and their jobs versus the value of other people who are harmed by the coal burning, or the country or the world where global warming? These are not decisions economists make easily, because how do we value? How do we value that job versus how do we value tuna versus how do we, you with me? These things are hard to value. If we're going to go cut some trees down, and we're cutting down the Amazon, every year we lose more and more of the Amazon so that they can do farming in Brazil. What's the value of a tree? We know that the Amazon is the air conditioner for the planet Earth, and if we cut it all down, the planet's going to scorch. How much can we cut down? What's the value of the trees we cut down? If we cut down trees, the United States used to be covered with trees. There aren't a lot of forests left. What's the value of cutting those trees down? What's the value of a tree? How do you value these things? Very, very difficult to do. Hydraulic fracking. Oil companies can pump water and other chemicals down into the ground, cracks the ground, lets them get far more oil and natural gas out of the ground than they could before. Really good for those companies, really good for their employees. They've had earthquakes in Pennsylvania because of it. They have contaminated groundwater where some people were farming because they had a well, and now their well is full of chemical contamination because of the fracking. What's the trade-off? How do we value the value of the fracking and getting the oil and the gas out versus the earthquakes and the underground water contamination? How do we value that? How do we figure it out? That picture there is Glenwood Canyon. And if you've ever been to Colorado, that is one of the most scenic drives you will ever take in your life. That's the Colorado River cutting through Glenwood Canyon. There's a rule that says you have to build an interstate highway a certain way. Well, they would have had to rip up Glenwood Canyon to do it. And if you drive that road now, you will discover that they built a really nice road through there, and it's 2 lanes both ways, and it's a beautiful road to drive. It doesn't quite meet the requirements of an interstate highway, but they got the government to bend the rules. The state of Colorado got the government to bend the rules. For many, many years, if you drove from Denver to Las Vegas, there was this little stretch of 20 miles that wasn't finished. It was a 2-lane road. So you drive on big freeway, down to little 2-lane road, back onto big freeway. The federal government was all, you've got to do that. The state was like, no, we don't. And they worked something out. They worked out a rule which is to the benefit of everyone, a coast solution, right? You work something out. You negotiate something that works. And so we have this beautiful, gorgeous Glenwood Canyon where the road fits into the canyon really nicely, and it's beautiful. Here in Nevada, we get to deal with all this nuclear waste stuff. The nuclear industry only survives in the world because it's government subsidized. Nuclear power is not profitable if it's not government subsidized. There's nowhere on earth that nuclear power makes money without help from the government. The government takes care of, or is supposed to take care of, dealing with all the waste, the nuclear waste. So you've got highly radioactive stuff that you're taking out of these nuclear reactors that's going to stay radioactive for tens of thousands of years. And the government has taken responsibility by law to do something with it. Without that government involvement, no insurance company would ever insure a nuclear power reactor. And if you understand Chernobyl or 3 Mile Island, you should understand why that is. But they could not get insurance if it weren't for the government. Now they want to take that nuclear waste and they need to put it somewhere. And most of that nuclear waste is still sitting at power plants. It's sitting in little swimming pools at the power plants. It has to go somewhere. So they did a project where there were 3 different places they looked at of where to put it. Let's just say that politics being politics, they just kind of stopped the science and they picked Yucca Mountain, and then they only studied Yucca Mountain. The other sites they stopped, and that's because senators from those other states got themselves put on as chairs of various committees in the Senate, and they stopped their sites from being studied, and only Yucca Mountain here in Nevada was studied. The whole transportation system, if they open Yucca Mountain and you live within a half a mile of US 95 from the Spaghetti Bowl out through Centennial area, you'll get the equivalent of 1 or 2 chest x-rays every year from trucks driving by moving the nuclear waste to Yucca Mountain. How do we value that? What's the consequences, the health consequences to all those people of getting that quantity of radiation? How do we value that? Then Yucca Mountain itself is a dormant volcano. It's not an extinct volcano. It's a dormant volcano. It's not likely it's going to blow up. But the ground underneath it still is part of a system. And eventually the nuclear waste in there is going to leak. And it's going to get into that water table. And that water table heads over into California. What's the cost? What's the impact? What's the... right? And so 2 things here. One is Milton Friedman, who didn't think too much of him, and most of his economics has been thrown out as being wrong. But there's parts of Milton Friedman that everybody still uses, and one of those things is this Tanstoffel phrase, which is there ain't no such thing as a free lunch. You never get one thing without giving up something else. You never have a benefit without a cost. Everything we do to fix global warming is going to hurt somebody. Everything we do to deal with nuclear waste is going to have negative consequences. There's no way not to have negative consequences. We have tens of thousands of pounds of highly radioactive nuclear waste sitting all over the country. There is no way there can't be a cost to dealing with all of that nuclear waste. There are always these trade-offs. Part of the problem with this is what we call discounting. How do we value the future versus how do we value today? How much should we care about our grandchildren's lives relative to our own? Most people, it turns out, discount the future. Most people, it turns out, even though they say they're worried about their grandchildren, they're worried about whatever, they won't change their current behaviors because of something that's going to happen 50 years from now. They just don't. Most people don't react that way. They don't value the future very much at all. People don't save enough for retirement because they don't look at the future and so on. So there's this whole problem of how do we value the future? How do we figure out what these trade-offs are? So are electric cars more environmentally sound than gasoline? And well, where does electricity come from? If you're generating electricity from solar, then an electrical car, fairly environmental sound. That's pretty good environment. That means you're driving your car based on sunlight. Good thing. If that electric car is coming from electricity for it's being generated by a nuclear reactor or by coal, is that better than driving a gasoline car? I don't know. And then electric cars have batteries in them. And those batteries don't live forever, and at some point you have to do something with that battery. Well, those batteries are full of highly toxic chemicals and elements. There's acids in them, there's heavy metals in them, there's very toxic stuff in those batteries. Well, what's the environmental cost of getting rid of those batteries? If every car is full of batteries, and every 5 years all those batteries need to be replaced, what's the environmental impact of that? So it's not just obvious that electric cars are better than gasoline, or particularly something like liquefied natural gas. It's just not clear that we shouldn't be driving cars on methane or hydrogen or right? Costs and benefits. Whatever system we have, there are pluses and minuses, and every problem we create, every problem we solve creates another problem. And the trick to life, and this is one of my laws of life, the trick to life isn't solving your problems, because you never do. The trick to life is replacing big problems with littler problems. And every time you encounter a problem, you have the problem you cause needs to be smaller than the problem you fix.